Now let's look into the second type of embedded type feature selection algorithm, which is ridge regression. So ridge regression, also known as Tikhonov regularization, it is an embedded type feature selection method that combines feature selection and model training into a unified process. It's a regularized regression technique that can handle multicollinearity. So what does multicollinearity means here? So the high correlation between predictor variables, or the high correlation between features, and this is going to prevent overfitting. So to put it, I'm just going to repeat one more time. So it's a very important aspect of ridge regression. So ridge regression is a regularized regression technique that can handle multicollinearity and prevent overfitting. So now let's look into the definition and explanation of ridge regression. So ridge regression is a linear regression algorithm so that adds a penalty term to the sum of the squared residuals in the object function. So the penalty term is proportional to the square of the magnitude of the coefficients. So by adding this penalty term, ridge regression shrinks the coefficient estimates towards the zero, reducing their variance, and that's what a ridge regression do. So now let's look into the applicability. So ridge regression is applicable to both single sample and multi-sample data sets. So it can be used when there is a multi-collinearity among the predictor variables and when it is necessary to control the complexity of the model. So I'm repeating this. So the most important point is applicability, which type of where it is applicable. So applicability, so it can be used when there is a multi-collinearity among the predictor variables and when it is necessary to control the complexity of the model. So now let's look into the mathematical equation or formula. So the objective function for the ridge regression can be written as this. So RSS ridge of W comma P is equal to, so this portion handles fit training data well, and then a remaining portion keeps the parameters small. So this portion, the second portion, is called as a penalty term. L2 penalty. L1 we have seen in lasso. L2 is in ridge regression. So L2 penalty or penalty term or regularization term. So alpha times sigma of J is equals to 1 to P, and W, this is nothing but the coefficients, sum of coefficient. So this penalty term is proportional to the square of the magnitude of the coefficients. So by adding this penalty term, ridge regression shrinks the coefficient estimates towards zero, reducing their variance. Okay, so that's what is the penalty term. So penalty term is nothing but the summation of the square of the coefficients, and the main target is to keep these parameters small. So a trade-off between fitting the training data well and keeping the parameters small, and so this is called as the objective function for ridge regression. And here y is the vector of target values, and x is the matrix of input features, and w is the vector of coefficients to be estimated, and alpha is the regularization parameter that controls the strength of the penalty term. So next, when RSS is the residual sum of squares and alpha is the regularization parameter, the regularization parameter controls the amount of shrinkage applied to the coefficient. So higher alpha value, so here that you see alpha value, A higher alpha value leads to the more shrinkage, reducing the impact of the predictor variables on the model. So that's what you have to make sure of when you do the fine tune of the alpha value. Then how this algorithm works, that's what we're gonna see. We are gonna see algorithm working process. So load and pre-process the data set, then split the data into features capital X and the target variable small y. Then standardize the features using a suitable scalar. Then create the ridge regression model. Then fit the model on the training data using fit method and retrieve the coefficients from the model using coefficient underscore attribute. And the last step is to evaluate the model's performance on the test data using appropriate evaluation metrics. So this is how our algorithm works. Now let's move on to the applications of ridge regression. So ridge regression, predictive modeling tasks where there is a need to handle multi-collinearity and prevent overfitting. This is very important aspect. Where do you use a ridge regression? So ridge regression can be used in predictive modeling tasks where there is a need to handle multi-collinearity and prevent overfitting. Then we have the regression problems with a large number of predictor variables, and the final most one is the financial forecasting, such as stock price prediction, where predictor variables may be highly correlated. Now let's look into some of the activities or some of the models that we can build out of where the ridge regression comes for our rescue. And first one is housing price prediction. So predicting the sale price of houses based on various features such as the number of bedrooms, square footage, location, etc. Then we have the customer churn prediction, predicting whether a customer is likely to churn, stop using a service based on their demographic and behavioral features. Then we have a credit risk assessment, predicting the likelihood of default on a loan based on credit history, income, and other relevant features. So this is what a ridge regression. Note the ridge regression algorithm can be implemented using various libraries such as scikit-learn, stats models, and TensorFlow. So the specific implementation may vary depending on the chosen library.